Hello, this is the class of data engineering, and in this section I would like to explain about the data integration. The issue that we are going to learn here is about the data integration and data integration issues, schema-based approaches, instance database approaches, and how to handle the data redundancy and inconsistency. Okay, so I will split these videos into two sections, so we can have some break and in the middle of this slide. So what is data integration? When we are doing with the data engineering, actually we need to understand about the data quality. What is the data quality when we are dealing with the data integration? Yeah, it means we are making the data integrate into one, and we are going to use the integrated data for the data analysis. And inside of this data quality, there are many other parts of the data pre-processing part, like data cleaning, or we can do the statistical data analysis. We can do with the management information systems. We can use also the knowledge representations for improving the data quality. The data mining is also used for the data quality. And for the data integration itself, there are many issues like source selection, source composition, query result selection, time synchronization. And if we are dealing with the data cleaning, we will also check later how we can deal with the record matching and data transformation. And for the intersection between the data integration and data cleaning, we will deal with the conflict resolution or record matching. And in the other part of the data quality, like statistical data analysis, we will deal with the edit imputation, record linkage. In the management information system, we will learn how to assess, process improvement, how to trade off between the costs and the optimization. But I think I will not discuss the management information system in our class. For the knowledge representation, I think we can discuss a little bit on that issue. And of course, in the data mining, you have another course for discussing data mining stuff. So what we're going to learn in this part is more about the data integration. So what is data integration? In the data integration, by the definition, it is the combination or how we can combine the data into one coherent store, and the data actually is multiple sources data. So when we have the multiple sources and we want to make it into one coherent store, of course we need to identify the entity. How can we identify the entity? For example, we want to identify the real world entities. For example, the Bill Clinton. I think if you are the old generation, I guess what the one of the president in United States. The name is Bill Clinton, and his name actually Bill W. Clinton. In some of the news, they mention William Clinton. So they have different texts, but actually they refer to the same name. And the customer ID. When you are dealing with one country, you may use the customer ID with this format for the column name or for the attribute name. But on the other hand, some people, they will use the customer shop to identify the customer ID. So using this kind of representation is a kind of problem, because we need to identify this kind of issue. And the data value conflicts. So the data value conflict means for the same real world entity, attribute values from different sources are different. So for example, if we are using the different representation or different scales, if you are in the British, yeah, you might use the British units, but if you are in the US, you might use the US units. Let's say in Korea, we use like meter, okay? But in British, you are in USA, you may use feet. Okay? So it's different for this measure, and yeah, you need to handle those kind of issue when you integrate your data. So in this lecture, we are going to learn at least two issues. First is about the schema. Yes, if you understand the database, okay, we have the entity, and the entity, we can develop the entity relationship diagram. In some other literatures, they mention as a schema. Okay? So each tuple from a particular data source contains a schema which might be similar to the tuple in other data sources. So in this case, yeah, we want to check whether the entity, the ERD, or yeah, the schema in the database one, it is the same with the schema in ERD2. If they are the same, then you can just integrate. But there are also another issues. We can deal with the database. It means maybe the schema name is the same, but the value or the instance or the object is different. Okay. So in addition to the schema-based issues, we can also deal with the database integration. And it is more challenging in the data integration processes. So yeah, we are going to deal with the issue. So the first is about the schema base. So we are going to check how many of the issues in the schema base. Okay. To deal with the schema-based data integration issues, we can adopt some methods from database integration approach. The first is the schema translation, and the other is schema generation. So for the schema translation means it is the component of database schema. It is translated to a common intermediate canonical representation. Let's say I have one the database schema. Okay, so I have a lot of database schema, and we are going to let's say this is the schema one, and then we have the schema two. Okay, and then we will translate into the common schema. So when we have the common schema, then we will use this common schema for our integration. Or the other is we can call it the schema generation. So if we want to use this schema generation, the intermediate schema are used to create a global conceptual schema. So we have the global conceptual schema. So let's say we have schema 1 and schema 2 and schema 3. So we have the global one. So every of the schema should refer to this global conceptual schema. So this is one example. If we have the order, then we have the client, we have dates, we have products. Okay, and in one company they may use orders. In other company they may use maybe not order but the customer orders. Okay, so yeah, different name. Now you refers to the same entity, but when you do the integration, you need to pay attention how to combine between the customer orders and orders. Okay, or maybe in the other kind of database they use the supplier order. So those kind of uh, different representation, yeah, you need to make it as a global conceptual schema. So for example, I will just use order. So every order will connect to the order number, order date, and order amount. Okay, so those are the basic element that you should have. Okay. Okay, so we will deal one by one. Okay, what is the meaning by schema translation? Okay. First, before we deal with the schema translation, we need to understand what is the canonical data model. The canonical data model, it means it is a kind of um, relational. Okay? So if you understand the ERD, okay, so it is the entity relationship diagram. It is a relational. The data model is relational, and yeah, usually we use the entity relationship. Okay? In the entity relationship diagram, yeah, it use like the database intentional knowledge extractor. So we can have the knowledge from the database, and yeah, we extract it. So we have the entity relationship after we extract the knowledge. Object oriented is another way to do with the canonical data model. There's another term, we call it Artemis. So Artemis is a process model analysis tool environment for object oriented and entity relationship modeling. There is another way for doing the canonical data model. They call it as graph oriented. In this graph oriented, they have the DIPE, so it is for the distributed environment. Yeah, there are some other methods like trend, CM, comma, Cupid, okay. And the graph oriented are preferable using the XML. And because they are using the XML, there is no common graph formalism, because it the canonical data model, it really depends on data, but they can also use the graph in order to translate the schema. Some other works, they are creating the mapping algorithms to deal with this schema translation. In the schema generation, yeah, there are at least 3 ways for the schema generation. The first is about the schema matching. We are making the schema, we know the schema and we want to match each other. It means we are trying to find the correspondence between the multiple schema. Schema integration is another way. Instead of matching, we will integrate, and the integrate is to create the global conceptual schema. When we have the global conceptual schema, yeah, it will be used for the mediated schema, and it is the correspondence. There's a correspondence between, yeah, as I mentioned to you, we have the global conceptual schema, and it will refer to the other schema that you want to integrate. Okay? Schema 1, schema 2, schema 3, schema 4, and so on. If we are dealing with the schema mapping, it means we want to map the data from the local database to the global conceptual schema. And yeah, if we have this global conceptual schema, then yeah, we want to map. Important. Sometimes the GCS or the global conceptual schema is defined first, and schema matching and schema mapping is done against this target GCS. Okay, so for the schema matching, it is possible to use the GCS, and for the schema mapping also it is possible to use the GCS as well. Okay, so yeah, sometimes the GCS is developed first. So in the example, actually, you can have, yeah, there are many examples for the database, but I would like to use this one. The relational model, we have EMP. Let's say this is employee, okay, and then I have procs. This is a project, and then assign. Okay, so this is assignment. And then pay, so this is about the salary. Okay, So you can see that ENO is the employee number, and then E name is employee name, title. Maybe he is a manager or he is a director and so on. The project is related with the project details like the project number, the project name, and how much budget that will be allocated to the project, and the location of the project, and C name is the customer name. And this assign, we have the employee assigned to that project, okay? And what is the responsibility and the duration. And then the payment, it depends on the title, okay? So the title here, maybe if he is the project manager, then yeah, maybe the salary is higher than the common employee, okay? So with this kind of things, we need to understand the relational. And when we have the relational, we can create the ER model. So the ER model, I think if you understand the database, yeah, we have the ER diagram. Okay? This is one of the ER model. So when we are dealing with the schema matching, it means we know that the schema is heterogeneous. Yeah. The schema heterogeneity cause the schema matching is necessary for our integration. And there are two kinds of schema matching. The first is the structural. So if it is based on the structural, then we want to find only the structure. Let's say, yeah, this is the customer, this is the S1, and this is the S2. And the first S1 is the name S, the CUST, but the second is customer. Actually, in the structure, they have similar, okay, but they don't have the OMER in his case. And then the customer ID, okay, it is so the same, but only the different name. Company, yeah, C name, actually the same. First name, yeah, is contact, okay, but okay, this is a little bit different because it is the last name, but it is about the phone. Okay? Then, yeah, if we are dealing with the structure like this one, actually we need to find like the type conflict. Okay? If it is the string, and then if it is string, then it matches. Dependency conflict. So if this customer ID will go to another kind of table, and this also go to another kind of table, and they have the dependency measure like the cardinality, one to many, okay, one to many, and then this is also one to many, okay, then it fits. But if it is different, then yeah, there will be some conflict. Or we can see also the key conflict. Where is the key of this one? Okay. So you know that in the database we have the primary key and we have the foreign key, whether it is the key or not. If it is the key, then yeah, maybe in the structure they are the same. And behavioral conflicts. So the behavioral conflict means if we have in the programming, call it is a method. Yeah. So if it is a method, then let's say if we have the foreign key, yeah, the foreign key usually will connect to another primary key. And if they are connected, then there will be some like cascade relationship. Yeah. So the relationship, if they have the relationship between one table and another table, okay, we need to check if maybe S1 has the relation with S3 and S2 will have the relation with S4, but S3 and S4 are different. So they have the different behavior. Okay. For the semantic, okay, is more complicated. Okay. So if it is more about the semantic, it means is more about the synonym, homonyms, or hypernym. So this is more in the textual. Okay? And sometimes the database, they have the ontology. And if the person also use wording. Okay, it's different. Like this one, C and shop, and then this is customer ID. So this is the wording are different. So in this case, yeah, you need to consider those part. Okay? If I give you another example, for example, this one, this is the structure. Okay? Let's say the data type is string, okay? The field name is username, and the other schema, it use long, even though this is the user ID. Okay? And then we can see this one, the username is string. Okay, then it matches. What about this one? Favorite number for the schema 1, and then this is the schema 2. So this schema 2 is about the reader, and the schema 1 is about the writer. Okay, the favorite number, they have the data type as the same with the field name, so we can match this one. If it is the interest, okay, so this is array string. Okay, this data are matched, but this data is different. If you want to check also from the semantic, yeah, let's say this is the SSID and this is ID. So you can also measure, like for example, based on the attribute and the data type. If you want to check one by one, then you may have different, let's say the P name, okay, and we have the first name and last name. And here we have the P address 1, P address 2, but here we have only address 1. So this kind of schema matching is very crucial for the data integration. Other complications, actually, it can be related with the insufficient schema and instance information. Maybe you know that these are related with the interest. But what is interest? We don't have sufficient information about this interest. And photo URL, it is about string. In the data type, this is also string. Okay, so it's a little bit confusing, but using the schema matching, yeah, we need to understand that there are some complication with this one, or unavailability of schema documentation. So that's why when you are doing the database, yeah, it is important to document the data schema. Okay? And subjectivity of matching. Usually, if we cannot figure out the schema, then yeah, we need to and we need to rely to the experts, or we need to rely to someone who know about this domain. Okay? So some issues that affect the schema matching, for example, yeah, whether we are going to use the schema or we are going to use the instance, is important, and whether we are using the element or we are going to use the structure level, or are we going to use the cardinality. So there are many issues when you are doing with the schema matching approach. So yeah, there are some other schema-based matching approach, and we're going to discuss the details of this one. And let's say first, when you are doing with the schema matching, if you are dealing with the semantic, okay, if you are doing with the semantic one, of course you need to understand the linguistic. Yeah, it is good if your schema is using English. So when you transform the schema to another database schema, that at least you have the same language. But if you are using different language, so it is another issue. Okay. So in the linguistic schema matching, we use the element names and other textual information. Let's say the textual description or some annotation. Okay. And we can use the external sources. Let's say in English, you have the thesaurus. So it is like the dictionary, but it's more content. Okay. Let's say I have the schema 1, okay, and then I have the dot element 1, and I want to check whether it matches with the schema 2 in the element 2. and then I have P, and then I have S. What is P? So P is the predicate, and S is the similarity value. So for example, I want to check if the schema 1 and schema 2, if I use the predicate. So the predicate, if it is using the similarity, and let's say I use the similarity with the Euclidean distance, for example, or maybe this is not Euclidean distance, but Chakart. Okay, so Chakart is possible for text, and the similarity value of S, maybe I just set that it is, if it is higher than 0.6. Okay, then yeah, you can say that those two schema match. If we are dealing with the schema, okay, so it means we deal with names of the schema elements, and yeah, we can handle the cases like the synonym, homonyms, hypernyms, data type similarities. Maybe we will learn a little bit about this one. Okay, the what is synonym? Yeah, synonym is about different name. Okay, if you have the maybe the synonym of use. Okay, so we can use utilize. Okay, so they are synonym. Okay. Homonym, yeah, homonym, it means we have in the same phrase. Okay, homo means homogen. Okay, and then name means the expression. Okay, if we have the hypernyms, okay, the hypernyms, we can have like this one. We can have the hyponym. It means this is more detailed, and hypernym, it is more in the top level. Let's say the color. Okay, the color is the hypernym, and if we are using the detail like red, white, and black, yeah, it is the hyponym. Flower is the hypernym, and then rose, jasmine, orchid is the hyponym. Yeah, you can refer to this one. Let's say if you have the I don't know, purchasing. Okay, so if you have the purchasing data, and then if it is the hypernym, okay, then the purchasing can be split it into the purchasing of item, okay, or the purchasing for the maintenance, okay, if it is in the industry, okay, or it is the purchasing for any stationery. So the item is more about the product itself. Usually the product is related with the manufacturing product. The maintenance, it is for the spare part for the machine. Okay. Stationery, so if you have the office, so you want to buy like table, or you want to buy chair, so it's not related with the product for the manufacturing, but yeah, it's for the daily activities, like for the officer who want to do the activity or inputting the data or doing the report and etc. Okay. So they can also have this one. And sometimes, yeah, in the department, in the industry, they will split the item purchasing, the maintenance purchasing, and the stationery purchasing. This about the schema. But what about the instance level? The instance level, yeah, we can focus on the information retrieval techniques, such as how many words are there in the instances, and then the key terms, yeah, and we can deduce the similarity from this one. When we are doing with the linguistic, okay, means we have some rules. Okay. Basic rules can be handcrafted or maybe discovered from outside sources. If you are using the text mining, okay, you will understand we have the word net, predicate, okay, predicate, and similarity value. So the predicate means something that you want to define about the function or something that you may use to check the text. Okay? So let's say the handcrafted is more specified, but when you want to discover, so maybe it can be computed or specified by an expert after discovery. So let's say if we want to check the uppercase name and lowercase name. So the uppercase name, when it is like equivalent to the lowercase name, and if it is true and the true is equal to 1, okay? Or the uppercase name is equivalent with the capitalized name and true and it is 1, and the capitalized name equivalent with the lowercase name, it is true, then yeah, it will also equal to 1. Okay? Or we can also deal with the, for example, DB1. We have the database 1, and then this is the attribute or the column ASG assignment. Okay? So it is equivalent with the DB2, and the name of the entity is works in. So the predicate will be true when the similarity value is 0.8. So you can define like this kind of function. So there are some automatic discovery of name similarities. We can use affix, or in the text mining, we call it stammer. It will use the common prefix and suffix between two element name string. You can use ngrams. Okay? So it means we can compare how many substring of length n are common between two name strings. So you can use unigram, you can use bigram, you can use trigram. This is for the computational linguistics. And you can also use edit distance. It is based on the number of characters modification. So you can see how many addition, how many deletion, and how many insertion of the letters that needs to be performed to convert one string into another. Some cases they will use Sundex code because it can be more precise when you are doing the integration. Okay? So we will take a look on some examples, and also look at the data types. Okay, so this is the manual, but it's not that manual because it's semi-manual. You will check the data type similarity, may suggest stronger relationship than the computed similarity using this threshold or differentiate between multiple string with same value. So we can see one by one. Okay, affix. What are affix? If you follow the NLP, natural language processing, there are some variants about affix. Okay? If you do the stemming algorithm, we have Porter, we have Lovins or Pice, and yeah, there are many other affix, the stemming algorithm. The affix stemmer attempt to find the common prefix and or suffix. Okay. Yeah, I think I will just use very simple stemming like Porter. Okay, and you can see some example later. Let's say if you know the suffix. Okay, so I put this one suffix nus li, okay, able. So it is in English. Okay, of course, yeah, if you are using with your own language, the meaning will be different. So nus, it means like. Okay, so happiness is like happy. Okay. Something with li, it is in the manner of something, it is likely. Okay, and so on. And yeah, if you have the suffix, yeah, you can delete the suffix to represent the original word. Okay. Or you have the prefix. Okay, this is the prefix. So the prefix is like dishonest, then it means not to be honest. Rewrite, so it means to write again. So this prefix can be eliminated to make it more easy to understand. And there are some other examples like operational and research, operating and system, operative and dentistry. So this is more a semantic and is more complicated when you are dealing with the affix. So when you do with the stammer or when you do with the porter, you will eliminate, you will delete. For example, the SSES, you will just replace with SS. For example, classes, you will eliminate into class. Or for example, rational, motivational. So you will delete the ational and then it becomes E. So for example, relational, you will change to relate. That's the way Porter algorithm did. Ngram, okay. In the Ngram example, we usually use this N to represent the number of character that you are going to use. So N will be any integer value to represent the letter. Let's say I have responsibility and then I have 3 grams. So I want to find any of the 3 letters. So it can be RES, it can be IPI, it can be PIL, it can be ILI, it can be LIT, and it can be ITY, okay? And it can be SIB, ESP, SPO, PON, ONS, and SI. Okay? And yeah, based on this one, we can say like there are about 12. Okay? So there are 12. The 3 grams, we have 12 of the 3 grams. And let's say, if I want to know the RESP, yeah, in the RESP, the 3 grams, we have only 2, so RES and ESP, okay? RES and ESP. Then it means the 3 gram similarity. So if I want to check this versus responsibility, okay, if we deal with these 2 words, then the 3 gram similarity is we have 2, yeah, we have 2 over 12, the overall of the responsibility, and the Ngram similarity is 0.17. Yeah. If we are dealing with the edit distance, the edit distance means I have the same words, responsibility and RESP, and we need to find the possible deletion. We want to find the possible deletion. We want to find the possible addition, and we want to find the possible insertion. And we are making this responsibility to RESP. It means we will delete. What is the deletion? So we will delete the ONSIPILITY. Okay, so we will delete this. If we convert the RESP to responsibility, then we will add the characters ONSIPILITY. Okay. Then how many edit operations that require for this one? Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there are 10. Then the number of edits required is 10. Yeah, if you have the same like 10 and 10, yeah, it's good. If you have not same, then usually you can determine like the maximum or like the mean. Okay, so it depends. In this case, we want to calculate the similarity. The simple way is just 1 minus 10 divided by 14. So 14 means the number of the maximum string that we have here, and the result is 0.29. Okay, so this using the edit distance, just the simple edit distance. Okay. With the Sundex code, yeah. So, the meaning by the Sundex code is we are going to make the letter, okay, begins with the first letter of the surname followed by the 3-digit code. And it will represent the first 3 remaining consonants. Now, let's say I don't have any good example, but you can see here, outreach. Outreach. If I want to make it as a Sundex code, then I need to check what are the letters coded. Note that this one, the letters A, E, I, O, U, Y, H, and W are not coded. So there are no code for these letters. But for the other letters, we can code into 1, 2, or 3, 4, 5, and 6. You can see the letters here. Okay. Now, you will see all reads. Okay, the first all reads. The all reads, we will check this on the Sundex code. So the first is okay, all reads. So A is the first letter. Okay, and then what we can do with this one is to represent with 3-digit code. But how can we define the 3-digit code? So we need to find the letters coded, and this letter coded should be after A. Okay, so it means L. L, we have double L, so we will just choose only one. Okay, and then after L we have R. Okay? And then after R we have I. What is I? I, there is no code. Okay, so we'll go to the next, which is C. So we have L, R, and C. And we will check what is L. The code of L is 4. Okay, then we put 4. What is R? Okay, R is 6. So we will put 6. And then C. C here is 2. Then we will put 2. Okay. It means, yeah, we will use this Sundex code to represent the word already. Okay. And yeah, if we have the similar all reads, or maybe we have another all right, maybe, yeah, if the Sundex code are the same, then yeah, you can use it for the integration. Okay. Yeah, there are many other examples. You can follow this one. Okay. There's the in a matching approach. Yeah, of course you need to have the constraint. Yeah, data always have constraint and try to use them. So the data type information and the value ranges. Okay, for example, when you are comparing the RESP and the responsibility, yeah, the Ngram similarity is 0.17 and the edit distance similarity is 0.29. It is the lowest one. Okay. So if they come from the same domain, then this may increase the similarity value. Okay, because we are not sure whether they are in the same domain, but if they are in the same domain, then we can increase it. E and O in relational, yeah, we have the worker dot number and project the number. Okay. So how can we deal with this constraint? E and O and worker dot number may have type integer, while the project number may have string. Okay, then if you already see this kind of difference, then those two attribute does not match. So you can use this kind of constraint to identify whether the two schema in the schema base they can match or not. If you are dealing with the structural, yeah, in the structural, if two schema elements are structurally similar, then there is a higher likelihood that they represent the same concept. There is a higher likelihood that they represent the same concept. For example, in the structural similarity, they have the same properties, they have the same attributes, and the neighborhood. Okay, what is the neighborhood? Yeah, if we use the graph representation, the neighborhood is similar, or the set of nodes that can be reached within a particular path length from a node are the neighbors of that node. And if two concepts or nodes have a similar set of neighbors, then they are likely to represent the same concept. Okay. So it is just based on the constraint from the neighbors. So usually we can use the graph for this one. In the complex way, you can use the learning base. It means you can use the machine learning. Okay? And if you use the machine learning, it means you can do with the classification. So you need to check if you have this kind of element, if you have this data, okay, you can make something like the tabular format, and then maybe this is the X and you have the Y to represent the class. Okay? So you can classify the concept from various schema into classes according to their similarity. And those that fall into the same class, it represent the same, the similar concepts. Okay? And the similarity is defined according to the features of the data instances. If you understand these instances and these instances and these instances, yes, you can measure the similarity. And the classification is learned from the training set. So we can use this learning-based schema matching. For example, this one is the learning-based schema matching. Okay? You have the purchase order. And in the schema 2, you have P order. Okay? And then product, the schema 2 mentioned as article. And in the schema S, we have the bill to name and address. It is split. Okay? But in the schema 2, the name is payee and bill address. And the schema S contains SIP2 with name and address. So yeah, you can refer to the recipient and SIP address. Contact name and address, there is no significant relationship between the two. Then maybe the schema S1, the integration between those can be just the bigger one, which is the schema S, and we can just create the purchase order 2, and then we can integrate all those data into this schema S1. Yeah, so that's the one possible way. If we are dealing with the cardinality, it means we need to check the mapping element. Okay, the mapping element will influence the global conceptual schema. If you understand the database in the ERD diagram, it is if it is 1 to 1, or if it is 1 to n, or it is n to 1, or it is n to m. So this is 1 to 1, or this is 1 too many. Okay, this is the details in the database. Okay? And this is many to 1. Okay? Or many to many. Okay? So the idea of the database, you need to check in based on the cardinalities. Problems occur when the method could not match different mapping element. So if it is the global cardinality and the individual mapping element, the local cardinality. Okay? So for example, the price and the amount. Okay? And you can check, okay, it is 1 to 1. Okay, then yeah, the matching expression can be amount equals to price. And many to 1. So in the element level, for example, the price and tax and the cost. So there are many price and there are many tax, and if it is referred to the cost, yeah, then yeah, you can have the cost. It can be like an expression. So the price multiplied by how much percentage of the tax. So when you create a new cost, then you will just use this kind of expression. Or 1 to many, it means like name. You have the S2 element is first name and last name. Then it means when you create a new column or a new schema, then the first name and last name will be the extraction of name. Okay. If you have an NM element, okay, or the N one structural level. So it's more complicated. Okay, let's say I have the B title, the book title, and then this is the book publisher number, and then you have the publisher with the publisher number, and then the publisher name. Okay? And in the S2 or in the schema 2, you have the A, so it represents only the author, okay, author book and author publisher. So you can have matching between these two. So the book title, it can be referred to a book. Okay? It will be checked with the B title, and the A publisher will be checked with the P name. Okay, and then we can use the query. So select this one from BP, and then where the publisher number in B equals to the P publisher number. Okay. Yeah, you can have this kind of matching expression in order to match the schema. That if you want to combine, you can combine with the other. Let's say you want to combine the structural, and then you want to combine with the semantic, and then you want to combine with learning base. Yeah, of course, it's possible. Okay, so it is the combination. And we need to have the meta matcher. So it means the meta matcher integrate this into one prediction, and the integration may be simple or take average the similarity value or more complex. And if we are dealing with the schema integration, after we know about the schema matching, okay, so when you do with the integration, of course, you need to see the correspondence, how to create the GCS, the global conceptual schema. And it is mainly a manual process, although rules can help. Okay. We can say this GCS is based on domain knowledge, based on the expert. Okay. If it is a binary, you can just make a kind of ladder, or you can balance it. But if it is n-ary, n-ary, it can be 3-ary, or it can be 4-ary. Okay. 5-ary means there are 5 elements, or we can have the polynomial. Polynomial. Okay, so the polynomial means more than 2. So, or we can say also n-ary, and there are some ways, like whether you are going to one shot. One shot means if we have 5, for example, then 1 versus all. Okay, so all means the other, which is 2, 3, 4, and 5. Yeah, we can use this way, one shot, or we can have the iterative. So 1 versus 2, and then 1 versus 3. So we check one by one. 1 versus 4, and then 1 versus 5. Then after that, we want to check with from 2 versus 3, 2 versus 4, 2 versus 5, and so on. So it is the iterative for the integration. Yeah, there are many ways for this integration actually. For the binary, you can have stepwise. I want to check this schema and the schema, and then go to the next, and then this one I will check this schema, and then I will make this the more global, and then I will check with the schema, and I will make it more global. Or pure binary integration, it means there will be 2 schema, then I will merge here, there another schema I will do merge here, and then another schema I will do merge, like this one. Yeah, for example, if you have the first name and last name, so you will merge it into name, and then you have the salutation and name, and you will merge it into one. Okay, so this is the binary integration methods. So everything of the elements will be in the 2 levels. Or if you have the one pass, so in one pass means you can just 1, 2, 3, and then you will just integrate into one. And then if it is iterative, then yeah, you will have like this one, and then yeah, you will integrate in this one, and this part will be integrated one, and then you will integrate with the other part. Okay. And yeah, that's about the schema matching. Okay. And what about the schema mapping? Schema mapping, it refers to mapping the data from its local database to the GCS. So the GCS is the global, and while preserving the semantic consistency as defined in both source and target. Um, in the schema matching, usually if we are doing with the data warehouses, so this is the actual translation. And if it is the data integration system, you want to discover mapping that can be used in the query processing phase. We can call it mapping creation, or we call it as the mapping maintenance if it is related with the data warehouse. So when we are making the mapping, okay, so when we create the mapping, we can have the source. We call it, this is LCS. LCS is the local, okay, local conceptual schema, and the target is the global conceptual schema. And let's say this is the source. Okay, source is the SI. So we have the schema 1, the schema 2, schema 3, and so on. And we have the target. So the target is the target schema is the target 1, target 2, target, and so on. And we want to find the value correspondence discovered during the schema matching phase. So when we want to see the value correspondence, here we have a set of V, and V is the value that corresponds for matching between S and T. So it produces a set of queries that when executed will create the GCS data instances from the source data. We are looking for its TK, so we are we are looking for its target, a query QK that is defined on a possibly proper subset of the relation in S, such that when executed will generate data for TI from the source relation. Okay, so it means if we have the T, okay, and we have the S, so there will be a query, okay, and the query, when you do with the expression, with the query expression, then the data from the source can be transformed into the target schema without any issues, or maybe the highest similarity. So this mapping creation, we want to make a kind of query, okay, or mapping expression. So the mapping creation algorithm, the basic idea is we want to find the V. Okay, so the V is consider its TK, so the target, and then we divide the VK into subsets VJK. So its VJK is specify one possible way that the value of TK can be computed. So it's, oh, maybe this one is missing. So its query, okay, so it's of the query, each J can map to the query JK that when executed, it will generate some of the TK data. Okay. Oh, maybe this one is okay. Its value, this one. Okay. I think it's value JK can be mapped to a query QJK that when executed, it will generate some TK data. It means if I have the value, okay, so I already have the value, it can be mapped into this query. So when you map into this query, you will create a new data for the target. Okay. Then later on, you need to union for all the query. Okay. And after you have the big query for the K, then it will fit for the target K. Uh, I think I will stop here first, and I will continue with another video to explain this kind of database.